Alright guys, today we're going to look at this idea of transversals. There's a couple different aspects of this we're going to look at. First off, we have to understand what a transversal is. A transversal is a line that intersects a pair of parallel lines. And so if you look at this little diagram I've sketched here on the left, you can see these lines are marked parallel right here. And so that makes this line that intersects those two parallel lines a transversal. And transversals are pretty significant because once you properly identify one, there's a lot of relationships that you can pick up on and use to find a lot of unknown angles and a lot of things. And so I'm actually going to go through quickly, identify these angles as you can see in their relationships. I've got angles A through H marked on the diagram, and so I'm going to talk through these very quickly about these different types of relationships. So first off, you have what's called corresponding angles. And corresponding angles are angles that are on the same side of the transversal and they're equal in measure. So an example of corresponding angles would be angles A and E. Angles A and angle E, those would be corresponding angles. Angles B and F would be corresponding angles. C and G, D and H, all of those would be corresponding angles. And so, again, same side of the transversal, equal in measure. The second type you're going to see are called alternate exterior angles. Alternate exterior angles are angles that are on opposite sides of the transversal. That's what the alternate piece means. And they're outside the parallel lines. So angle A and angle H would be alternate exterior angles, or angles B and angle G would be alternate exterior angles. And the significance of alternate exterior angles is that they're equal in measure. And so that's what knowing that relationship helps you do. They're equal in measure. The next type is alternate interior angles. Alternate interior angles are also equal in measure, and they are on opposite sides of the transversal, and they are, but they're inside the parallel lines. And so there's two pairs here, angle C and angle F would be alternate interior angles, and angle D and angle E would be alternate interior angles, and they're also equal. Number 4 would be, now we're getting the same side angles, same side exterior angles. These are on the same side of the transversal, but they are outside the parallel lines. I've heard these called consecutive exterior angles. I don't really care for that term as much. I think same side exterior is a little bit more clear. And so this would be angles B and angle H, and then also angles A and angle G. And same side exterior angles are not equal in measure, they're actually supplementary, which means they add up to 180 degrees. And so there's a distinct relationship there. Same thing here, same side interior as well. And example of those would be angle C and E. Also angle D and F would also fall into that group. And so angle C and E and angle D and F. And those are also supplementary. They're also going to add up to 180 degrees. A couple other relationships I want to point out, and these are not exclusive to transversal angles, but they're very common on transversals, and so they're really important for you to understand. One is called vertical angles, which is a very common geometry term. Vertical angles are angles that are basically created by any two intersecting lines, and they're directly across from each other, and they're equal in measure. And so with a transversal, there are a ton of vertical angles. A couple of examples, angle E and angle H would be considered vertical angles, which means they're equal in measure. Angle B and angle C would be vertical angles. A and D would be vertical angles. F and G would be vertical angles. So there are a ton of these in transversals. And so they're all equal in measure, so it's just that distinct relationship. And then the last relationship, and again, this is not necessarily a term, again, exclusive to transversals, but it's certainly significant, and that's a linear pair. And a linear pair are just two adjacent angles that are sitting on a straight line. And so, for example, angle A and angle B are a linear pair, and another example would be like angle E and angle G. And a linear pair, those are supplementary. They add up to 180 degrees. And again, you look, just around a transversal, there are just a ton of pairs of these angles. And so all these relationships are extremely significant, and you can use them to find a lot of information. I'm going to very quickly kind of look at that. So here I've drawn a pair of parallel lines with a transversal. You can see I've got a known angle of 109 degrees, and so I could actually use that to identify the other values. And so, for instance, looking at this, if I wanted to know angle Z, well, angle Z in this 109 degree angle are corresponding angles, and so because of that, with corresponding angles, knowing that those are congruent, Z would also be 109 degrees. And then from there, there's a lot of different ways you could go about it. You could look at angle X, for instance. It's a vertical angle with angle Z, which means it's also 109 degrees. You could also have noticed that angle X and the angle that was 109 degrees were alternate exterior angles, which also makes them equal. And then you could look at angle Y. Well, that's a linear pair with X or Z, and so you would do 180 minus 109, and let's see, you'd get 71 degrees for angle Y. And so you can see just knowing these relationships gives you the ability to find several pieces. And also, where a lot of students get messed up is when you kind of take it to this next level, where maybe you don't have values that are known necessarily, or at least not known in their whole number value. But here I've got another transversal, and I need to make sure I mark these lines as parallel. Here I've got one angle that's equal to 3x and another that's x plus 20, and so it's kind of difficult. How do I do the relationship here? Well, looking at this, looking at the 3x, if I look at the angle here, it is corresponding with 3x, so it's also 3x. And then you look here, well, how is the relationship between the 3x and the x plus 20? Well, they are a linear pair, and I know that all linear pairs, even if they're marked with variables, are going to add up to be 180 degrees. So I can set up an equation to solve for x. And so here I can subtract 20 from both sides. That leaves me with 3x plus x equals 160. I can combine my like terms, and I get 4x equals 160. And then I can divide by 4, and I end up with x equals 40. And notice I'm not going to mark x as 40 degrees because x itself is not an angle. It's actually just a variable. And so you can see transversals, a lot of application and a lot of use.